Hi guys, so today I have with me a pretty interesting problem. I say interesting because it's a kind of like hybrid between 1D motion and forces. So I thought this is a really good question to do while I'm still, finishing up some 2D motion problems and I'm starting to introduce more forces problems. So I think this is a good like in between question. And before I actually go ahead and get started with this problem, two things. One, if you like my content, please don't forget to engage. So that means please don't forget to share with your classmates or friends. Please don't forget to like and subscribe if you find it helpful. And if you don't, then I'm sorry. I hope that you find another one of my videos helpful. And yeah, and my second thing I wanted to bring up is that this problem is not my own. I do not own any of the problems that I do. These are from Young and Freedman's University Physics textbook. I am simply producing and sharing a solution that is my own work. So just a copyright thing. Yeah, making that clear at the very beginning. Okay, so an electron mass is equal to 9.11 times 10 to the negative 31 kilograms, leaves one end of a TV picture tube with 0 initial speed and travels in a straight line to the accelerating grid, which is 1.80 centimeters away. It reaches the grid with a speed of 3.00 times 10 to the 6 meters per second. If the accelerating force is constant, compute A, the acceleration, B, the time to reach the grid, and C, the net force in newtons. Ignore the gravitational force on the electron. Okay, so in this problem, we don't really need to draw anything because, again, this is a one-dimensional problem. But I'm just going to go ahead and maybe like do a rough sketch. It's not necessary though, but yeah, let's just go ahead because why not? Okay, so let's say this is the tube. And let's say that this guy right over here is an electron, that blue dot. So what we want, well, what we know is that it leaves one end of a TV picture tube. To be honest, I have no idea what a TV picture tube is, and I don't really care, but I'm assuming it's some kind of tube. It's not really important to the question, so I'll look it up later, but yeah. Okay, so leaves one end of the TV picture tube, whatever that is, and it starts with 0 initial speed. So it's going to be like VI is equal to 0 meters per second. And it travels in a straight line to the accelerating grid, which is 1.80. So let's say that this is the accelerating grid. Okay, I'm just going to say accelerating grid. So AG. Again, I don't really know what an accelerating grid is, but again, not like really important for us to solve this problem. I'll look it up later, and I guess you can too. But I wonder if it's like one of those things where I don't know because so I'll go ahead and I'll say like my age. I'm born in the year 2000. So there's sometimes like I remember that when I used to be in physics classes, like my teachers would be like, "Oh, does anyone remember floppy disk or whatever?" And of course, my entire class would be like, "No, we have no idea what that is." And the teacher would be like, "Oh my God, I feel so old." But yeah, sorry. Maybe this is like one of those things where it's like I don't want to call it an old-timey thing, but a TV picture tube. Maybe it's like one of those TVs that are like three-dimensional. I used to have those as a kid. Okay, anyways, long tangent. Let's get back to the actual problem. An accelerating grid. In this distance between this accelerating tube and this grid is 1.80 centimeters. Okay, VF is equal to 3.00 times 10 to the 6 meters per second. And the accelerating force is constant. Okay, so we have these three pieces of information. So really, it's just like, again, a basic one-dimensional acceleration problem, constant acceleration problem, I'm guessing, because they don't really, yep, they say it's constant acceleration problem. So all we really need to do is write down what our knowns are. Okay, so our knowns, we kind of wrote them down, but let's write them down again. So mass, this electron is 9.11 times 10 to the negative 31 kilograms. VI, the initial speed, is 0 meters per second. the distance it travels is 1.80 centimeters. I'm just going to go ahead and quickly convert this. So centimeters to meters is divided by 100. It's going to be 0.0180 meters. And then VF is equal to 3.00 times 10 to the 6 meters per second. And we don't know what the acceleration is, but we do know it's constant. Okay, and that's what part A is looking for. We also don't know the time it takes, but we're going to figure that out. And the force, right? So what force is this? Those are the things that we're trying to figure out. But let's go ahead and get started with part A. Part A is looking for the acceleration. Now, if you notice, this is just a one-dimensional motion problem, right? So we have VI, right? We have VF and we have D, and we're looking for A. So what kinematic equation has VI, D, VF, and A? It's this one, right? So it's VF squared is equal to VI squared plus 2AD. And we want acceleration. So we're going to isolate for that. It's going to be VF squared minus VI squared. I hope I'm recording right now. Okay, I am. Okay. VI squared over 2D. And if we plug in all of our values, I get 3.00 times 10 to the 6 squared minus 0 squared over 2 times 0.018. Okay, acceleration, that means is, and I'm just going to plug this into my calculator just because I've noticed that, like, by the way, I appreciate it so much every time one of you guys finds something like, like a typo in my videos. But obviously it makes me feel like maybe I need to re-record the video after, because, I don't want to put false information out there. But, sometimes I get sloppy, I miss a minus sign. Ultimately, I know that all my final answers are correct because I do the problem beforehand and then I do the problem in the video. The problem's usually just like, well, when I'm like really focused on, presenting the solution, I don't look at my notes and then I miss a minus sign here or there, or like I write a number down wrong. So it's like all my solutions are correct, but sometimes the way I get there, it's I write something down wrong, like I forget a minus sign, or yeah, I write a number down wrong, and then one of you guys catches it, thankfully. Thank you so much for everyone who's been doing that. So yeah, I've just been trying to be like a little bit more vigilant into making sure that I'm not making those mistakes. Okay, so okay, awesome. So I think, yeah, okay, I got the same answer that I got before. So it's 2.5 times 10 to the 14 meters per second squared, and that's the acceleration. Okay, so that's for part A. I'm gonna write that down I hope, oh no, see, okay, I'm gonna try that again. It's so risky erasing with this new, I'm gonna search it up later. I hope I remember. 2.5 times 10 to the 14 meters per second squared. All right, and then yeah, meters per second squared. Okay. There we go. We got rid of the check mark without erasing anything else. Now for the risky part, let's get to part B. The risky part being, let's erase part A without, the eraser having, I don't know, it's a mind of its own and just erasing whatever it wants to erase. Okay. So part B, while I'm erasing, let me just try to multitask and talk about this part B problem. So part B, they want the time it takes to reach the grid, which to me just sounds like another kinematic equation, right? So this time we have VI, we have D, we have VF, but instead of A, I'm gonna do this in purple, we want T. Okay. So this is a little bit interesting because this is one of those problems where this is not really like an acceleration equation, but this is like a kinematic equation. And so because we know that acceleration is constant, we can use this equation right over here. And I'm going to explain it in a second, but distance is just equal to speed times time, right? But they said that, actually, let me do this. Let me write. So time multiplied by speed. But what is speed? Because we have VI and we have VF, right? So because acceleration is constant, we know that the rise from VI to VF is going to be steady. It's going to be a constant acceleration. So if we take the average, that's going to give us the average speed of the entire motion. So VI plus VF over 2. So that's average speed times time is equal to the distance covered. Okay. So let's do that. And really we're looking for time. So we have to isolate for time. So T is equal to D divided by VI plus VF over T. Awesome. Okay. So we're going to plug that in. T is equal to 0.0180 meters over 0 plus 3.00 times 10 to the 6 over 2. And when I plug this all into my calculator, I get, again, double checking my calculations, it's 1.2 times 10 to the negative 8 seconds. So yeah, that's the solution that I also got before when I did the problem. So yeah, that's our answer for part B, not part A. Part B. Okay, so part C, the net force in newtons. Okay, so for part C, I'm not going to erase part B just because I'm so afraid to erase. So part C is going to be the net force in newtons. So force is equal to mass times acceleration. So that's kind of the first time I believe we're using this equation, right? So that's Newton's third law, I believe. Or no, I think it's a second law. It's a second law. Sorry, I haven't done like these types of like, I don't want to call them like basic physics problems, but I guess like beginner physics problems in a really long time. So I forget like the order of Newton's 3 rules, right? So, or 3 laws. I don't know why I forgot that, but 3 laws, yeah. So the third one, I think it's like every action must be for every action, there's an equal and opposite reaction. Sorry, my mind, I don't even know why I hesitated there. But okay, yeah, every action has an equal and opposite reaction. And then B is the force is equal to mass times acceleration law. Okay, so force is equal to mass times acceleration. So this is meters per second squared. This is what I mean by I make like silly typos. But yeah, our acceleration is definitely going to be meters per second squared. Our time is in seconds. And then C, force is equal to mass times acceleration. The force is going to be, force mass is 9.11, like we said, like in our givens, right? We had to solve for that. We're just given that. So mass times acceleration, that's something that we solve for. It's 2.5 times 10 to the 14 meters per second squared. And for our final force, what I'm getting is 2.4 times, 10 to the 14 times 10 to the negative 31 times 9.11. And I'm getting, I'm actually getting something different from what I got on, like what I got when I solved the problem on my own. So I'm just going to plug it into my calculator one more time, just to make sure, because I don't want to have to re-record anything. Okay, yeah, for sure. So I punched in something wrong. That's why I got a different answer, but now I got the same answer that I had before. So good thing that I double checked. All right, so our force is 2.2775 times 10 to the negative 16 newtons. And I'm just going to double check or triple check one more time just because I hate getting things wrong. Okay, yeah, that looks right. All right. Okay, yeah. So we have, part A right over here. We have part B right over here, and this is our answer for part C. So 2.2775 times 10 to the negative 16 newtons. That is the net force in newtons. All right, so thank you so much for watching. I hope this was helpful. And if it was, please don't forget to like and subscribe. If you have any questions or if you have any questions, comments, concerns, please don't forget to leave them in the comments. I love reading your comments. Thank you so much to those of you who have been leaving comments. And yeah, as usual, if you know where to reach me, if you're too shy to go into the comments, you can always send me an email. It's in my About section. And thank you so much for watching. See you next time.